Ya, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello and welcome back with us in the Fundamental Physics 1 Practicum from Physics Laboratory 2020. Today, as seen on the screen, we're going to discuss uniform circular motion, which has two submodels, that is uniform circular motion 1 and uniform circular motion 2. So without further ado, let's study them. As usual, there are 5 outlines that we're going through this practicum. Let's take a look one by one. The first one is the objectives. There are two submodels of the uniform circular motion. Because of that, we have two parts of the outline that we're going through. The first one, uniform circular motion 1, has the following objectives. 1. Understanding the concept of uniform circular motion, and 2. Determining the amount of force that works on a spinning object. The second one, uniform circular motion 2, has the following objectives. 1. Understanding the concept of uniform circular motion. 2. Determining the amount of forces acting on a spinning object. It seems just like the first one, right? The uniform circular motion 1. But the difference is on the third point, which is determining the gravitational acceleration g by using the spinning liquid. Let's go to another outline, which is the basic theory. Circular motion is the motion of an object that forms a circular track and moves around a middle fixed point. The following are the characteristics of a uniform circular motion. First one is have a constant amount of linear speed, have a constant amount of angular speed, have a constant amount of centripetal acceleration, and the last one is have a circular track. On the screen, as you can see the table below, the unit of these magnitudes is very similar with uniform circular motion's sibling models, right? Who can guess it? Now if you guess it right, then you're correct. It's very similar with the uniform linear motion. The difference is simple. In the unit column, just change the radian by the meter. So in the position, the radian will become meter, and the velocity meter per second, and the acceleration is meter per second squared. And for the symbols column, sequentially downwards, change them by S, V, and A or alpha. So the acceleration is still the same. Now, uniform circular motion is the motion of objects in a circular path within a constant speed. That constant speed causes the object's rotation period to be constant too. A constant rotation period means in the same time interval, the objects will travel or sweep the same area. According to Newton's second law, objects that move in a circular order has the equation of force is the following. So it's the popular Newton's second law, right? Force equals m times acceleration, mass times acceleration. Downward, we derive the formula to become F(p), which means centripetal force equals negative mass times omega squared times radius. Now why is it negative? There's a reason for that. In this uniform circular motion, we knew that there is another force that works oppositely with centripetal force. What force is it? Yes, that is centrifugal force, even though centrifugal force is just a pseudo force, or we can say imaginary force. But in the reality, we knew that the motion tends to move the object's way as velocity go, which moves away from the central point. That's why the centripetal force who bind the object's way, so it stay in the circular track, are negative. And for the derivation of this equation is because omega squared equals alpha divided by radius, so it changes like this. Next, the uniform circular motion 2, determining local gravitational force. The picture beside is a flat vessel filled with water that is rotated using an electric motor. Do you guys remember when we were little, we used to stir water in a glass or a bucket so that the water turned in a circle, right? As we looked for a second after we stirred it, the water has an arc in it, right? That's the same like this flat vessel. The question is, how did it happen? It happened because of the force which are the centripetal force and the gravitational force in this case. The equation of water surface curvature can be expressed by y as height equals omega squared divided by 2 times gravity times x squared, or the width minus by omega squared times 6 times g times acceleration squared. Next, there are tools we're going to use in this practicum. For the uniform circular motion 1, there are 6 tools, including 1 electric motor with angular rate control unit, or some people call it speed control, 2 dynamometer, 3 stopwatch, 4 laser, 5 scalpel, and the last one is centripetal force tool, which is the important one for this practicum. There are several components in this tool. There are M as mass, C as mirror, B as bar, or iron bar in this case, a rope across the mass along the mirror, etc. For the uniform circular motion 2, there are 4 tools, in which 3 of them are the same as before. That is 1 electric motor, 2 dynamometer, and 3 stopwatch. Now the difference is on the 4th point, which is plastic flat vessel that works as our object practicum. Now let's go to the lab works now, shall we?
Now let me introduce the tools. First, dynamometer. Second, stopwatch. Third, plastic ruler 30 cm. 4. Speed control. 5. Electric motor with angular rate control unit. 6. Centripetal force tool. 7. Laser. 8. Scalpel. Now, I will explain the step of lab works. First, as we can see here, we have a laser with on condition. The laser will shoot a light to centripetal force tool, which is have a mirror component. The mirror will reflect the light to scalpel, like we can see here, the red light. Next, the electric motor will rotate to move the rotor, regulated by the speed control. Now, the speed of speed control will affect the centripetal force tool, so it will cause 2 forces. First, centripetal forces, which is go toward the tracks. Second, centrifugal forces, which is go away from the tracks. After that 2 forces, centripetal and centrifugal force, that will cause the mirror to rise. When the mirror to rise, the laser light reflected by the laser will increase. We go to the practicum. First, we need to collect the data first. The first step, we measure the radius of centripetal force using a ruler. The radius of centripetal force tool is 20 cm. The second step, we measure the mass of centripetal force tool using a dynamometer. Dynamometer serves to measure forces. Because it functions to measure force, then we will measure this mass using gravity. The result is 0.4 Newton, but because it is still in units of force, we convert it to mass units. So we will be divided 0.4 Newton with 10 meter per second squared is a unity of gravity. The result was 0.04 kilograms. Then after we determine the starting and final position, we will turn it. While it rotates, you can see a reflection of the light. The longer it will continue to move up. We wait until it is stable. After we determine the starting and final position, we will turn it. While it rotates, you can see a reflection of the light. The longer it will continue to move up. We wait until it is stable. We obtain the reflected light is stable at 50 centimeters. Now, you can write the number as the final position in the table. Now, after the light stabilized, now we will count the period. How to calculate the period? Period means 1 round. As we can see here, here is the black mark. When the black line meet again in the black line, it is 1 round. Let us begin. We count as many as 20 periods. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we get 60.87 seconds. After we have done the first experiment, now we go to the second experiment. The steps are the same. The first step, we determine the starting and final position. Here we get the starting position is 66 centimeters. When we pull it with the dynamometer, we will get the final position is 54 centimeters. Now, we will turn it and wait for the reflected light to stable. As we can see, the mirror light had stable at the 55 centimeters point. Now, you can write it on the table. Just like the first try before, once it's stable, you can calculate the period. Use your gadget or laptop at home. Now, you may try to count. Start. Now, we are going to do the last experiment. The process is still the same. First, we will determine the starting and final position. As we can see here, for the starting position, we get 60 centimeters. Next, we will use a dynamometer. We get the final position is 46 centimeters. Now, we will try to turn it. While it rotates, we wait for the light to stable. In this third experiment, the light stabled at 51.5 centimeters. Now, we will try the third. Same as the first and second experiment, we will calculate how much time it will take for 20 periods. We will count starting from now. After doing some experiments, now we fill in the table F of the dynamometer. How? The way is to use a dynamometer and come from the starting position to the final position at the table. For the first experiment, the starting position was 59.5 until 50 centimeters. Then we pulled it using a dynamometer towards the final position, which is 50 centimeters. Now, you try to calculate how much force did the first try get. Now, the second one, do the same. The starting position is 66 centimeter and the final position is 55 centimeters. We pull it using a dynamometer. From 66 we go to 55. Now look, how many newtons can you get from the second try? Now we will move to the third experiment. Same as the first and second before, the result of starting position is 60 centimeters. We pull it with dynamometer to final position at 51.5 centimeters. This third experiment we will try to see how many forces are there. Now try to see how many forces on there. Welcome to the second experiment of uniform circular motion practicum. As you can see, a bit different than before. Now, I will explain again the tools that we use. First, plastic flat vessel, different from the previous one. Second, same as before, electric motor with an angular speed control unit. Now, we will start the practicum. The principle is still the same as before. The electric motor is driven by speed control. When moved by speed control, the rotor will rotate. And when the rotor rotates, the flat vessel will form a curve like this. As you can see, this curve is formed due to the force of gravity. The gravitational force here is same as the centripetal force. Before we go to the practicum, first we will collect the data. Look at the flat vessel. In a flat vessel, there is water. The water parallel to this axis. If we equate with a Cartesian diagram, this is the x-axis, and this is the for the x, and this is for the y-axis. Meaning when the water and this is the x-axis, this is the 0 point. When n is at point 0, then the number 6 is -1, number 5 is -2, number 4 is -3, and so on. Now we will calculate the value of A. The value of A is the radius. For the radius we see 0.0 to the tip. Here we see there is a box. 1 square is equal to 1 centimeters. Now we will count it. 4, 2, 3, 4, 5, 6, 7. We got 7 squares, meaning the amount is 7 centimeters. You can write that the A value is 7 centimeters. Now we turn the electric motor using the speed control. Now we see in the column Y there are -1, 2, 3. The meaning is -1, that is the top of the curve of the water should be at -1. Now let us fit in the -1. Now you will count it for 20 seconds. But let it fit in the -1 first. Now, same as the try before, you can try to count it using a stopwatch at home, starting from now. Now we go to the second experiment. The second experiment we put y in -2. Then the peak point must be in -2. Now it looks like it is -2. Right? Now this is the third experiment. We put the y in -3. Now when it is raised negative 3, shall we try to calculate how much time it will take for 20 periods? Now try to count it. Thank you for the following circular motion lab until the end. I hope the knowledge you gained today can be useful for you. See you in the next practicum.